Hello everyone and welcome to our webinar. My name is Markus Eberle and I will moderate this webinar today. I'm very pleased that you took the time to participate, and way more important than myself are the two guys next to me, Adrian and Carlos. Welcome. I'm curious what we are doing today. The topic, as you know, is IC LEDs and in many perspectives. So I'm curious what we will see. Maybe before we start, for the people who don't know you already, you can give a brief introduction of yourself. Adrian, maybe.
Yeah, so I'm Adrian. I'm responsible for the EMC labs here in Germany. So what we are doing is pre-compliance measurement. So our main focus is supporting our customers with some EMC troubles, issues, and help them for the start of production, get everything ready, and have an EMC compliant product.
Okay. From my side, my name is Carlos Hernandez. I've been in Würth Elektronik since over 5 years, and I've been working in the development and also the final release of the IC LEDs. So really, I'm the product manager for this product, and I saw the process from the very beginning, the whole market research, the whole comparisons, analysis from competitors, from every single aspect. What can we do better, and what can we share with our customers, so the needs they have in order for us to promote and keep them like the best product in the market for this technology. Yeah.
Okay, thank you very much. So then, let's dive into the topic. We see, I see blinking LEDs, and Carlos, what do you have? What did you brought to us today? Maybe you can give us a little introduction.
Yes, of course. So the topic of the day, as you mentioned before, is IC LEDs. This is just our new component that we released last year. We're talking about intelligent LEDs, or also known as smart pixels, pulse LEDs, neopixels, dot stars. So there are a lot of names in the market, but they are pointing towards IC LED, which is the technology in where we have a digital component inside our IC, and it's in charge of controlling the single RGB chips in the same package. Meaning I can individually change the colors of every single LED in the strip via a microcontroller, and in this example with just one cable that is just sending data to the whole circuit.
That's interesting. So I think it's getting more intelligent now, and you have more possibilities probably then. So my question is, what can you do with it? What's a typical application? Yeah.
So for this technology, what you're looking for is these dynamic changes on your system. You want, for example, on gamers' devices like keyboards or the headphones, these change RGB dynamic effects. Or, for example, if you have a display, like here, the small one that we're offering, our FeatherWing, with just the LED set up on a matrix form, you can create different text, animations, emojis, for examples. And of course, the advantage here is the scalable technology. So what you're seeing here is the same like in a big panel, and it can just grow up, Other applications are, for example, big displays walls, or I don't know. Adrian, do you have other examples?
Yeah, well, I think it makes sense to use this technology for some mood lighting. So if you want to do more or less a lighting effect, and you want to have different moods, you're very flexible with the IC LEDs, I think. Also, when you're thinking of a professional use, that you're using it as an illumination of a device itself, background illumination, or as a decorative part of the wall, you could more or less use your company's colors, and you can also do flexible changes with it. And the good thing for the manufacturers, you only design one PCB, but you get all of the possible colors on it, so you don't need to more or less produce one element for a specific company or application, you can more or less use it very flexible. So one hardware, but a lot of possibilities, I think.
Very interesting. Cool. Okay. So yeah, there come a lot of ideas in mind, and probably on your side as well. But what do you have to be aware if you want to use it? Adrian, I know you also tested it in the lab and you made some experiences with it. What do we have to check before using it or be aware of?
Yeah, so we thought of where could be the challenges for our customers when they design in the product, and where could be the challenges from a whole application. And so we start more or less with the technology. So we have a microcontroller that is using somehow an SPI bus to control the single IC LEDs. And then you have this SPI string more or less. And with all asymmetric PCB buses, we have the issue that when they leave a PCB and they are routed in a cable, we can get emission and immunity issues. This is what we see a lot of times in our EMC lab, that someone is using I2C or SPI over a cable, and it's causing a lot of emission and immunity issues. And the same can be true, of course, for these LEDs. So what we did is we created a reference design, and we analyzed, for example, the difference between what's happening when you route the LED on a ground plane with the MCU together, or when you more or less just use a single side or PCB without a ground plane. Yeah, when you have only one layer or only two layers without a ground plane. So I brought for you some slides where we can have a look on the emissions when we are placing the LEDs on a ground plane together with the MCU on one PCB. And so we will get for the radiated emission up to 1 gigahertz, starting from 30 megahertz, the green emission curve. And you can see we are far below the class B limit here. So a lot of margin left. And this shows us when we do the design right, we can have a very good EMC performance here, especially now from emission point of view. Now when we start to reduce the layers in the PCB and we don't have the ground layer left, then we get the yellow curve. Means due to these ground loops that we will create on this SPI bus system, we will get a lot of emissions. And so this is the first thing we can learn here. We need to take care that we more or less have a ground plane on the PCB when we're using the IC LEDs and with an MCU.
Okay, and so what happens when, for example, the customer cannot use the microcontroller on the same PCB?
Yeah, that is always a big question, how to do this. So we also try to do some setup here. So you can see I've used the PCB as some saw, and I cutted the MCU here. So we placed it here, and then we are using a cable. So having here the signal line, VCC line and ground line together in one cable, and connecting this MCU PCB to our LED panel. So this is exactly what happens when you now have a far distant MCU with 1 or 2 meter cables, and then you have your LED string, more or less same like you can see here on this setup. And of course this is not preferable. Yeah? And why not? We can see this here now in the next slide. So we see in red the emission with an unshielded cable. So exactly the picture we seen before. And you can see the emission is rising up crazy. So we are far above the limit here. Yeah? So what we can do now, you can see I'm using aluminium foil in the lab, and I'm connecting it to the ground plane on both sides. So LED panel and MCU PCB have a ground plane, and we are connecting this ground plane on both sides with the cable shield, more or less extending now the return plane in the aluminium foil between the panels. So we have a good return plane for our signals. And then you can see we get a green curve. So more or less the emission is in the same way than when everything is on one PCB. Of course, the solution with the aluminum foil is not
I just
not preferable in an application later, and it's a typical EMC thing, maybe. Yeah. Cover tape and aluminum foil, typical for EMC labs. Yeah, but one solution could be we add a PCB clip on both sides where we can connect the shielded cable. So we are using a shielded cable with VCC ground inside, or the ground more or less is the shield and the signal line, and we are more or less connecting it on a clip on both sides here on the MCU and LED panel PCB. Could be an option. We did also some testing with filters. Filters are always critical in such an application because we more or less need to modify it to this special application. It's preferable to have something with a ground plane, so shielded cable connected to ground, or we could also think of using a flex PCB or two with a 2-layer connector between one of the PCBs to the other one. Could be also an option.
Okay, and all this information, can we find them an app node or?
Yeah, exactly. We created an app node, and I think the marketing guys will link this to this video. So we show more or less all the important stuff regarding EMC when you're using IC LEDs. So we discuss what happens when you use two PCBs. We also discuss the difference between a ground plane and without a ground plane, and we will also show a lot of the immunity stuff. Especially for the transient immunity, this can become challenging when you're using an unshielded cable between panel and MCU.
Very interesting. Thank you very much, Adrian, for this insight. Yeah, this is really nice to see. Yeah, that you also find a solution there, and there's already something ready to use, and you can go forward with it. So, yeah, as we also talking about digital kind of product here, are there also some software tools, libraries? You talked about GitHub and the FeatherWing. Yeah, what is there? What can I use already?
This is actually a nice question because, yeah, the products are getting more and more complicated. So smart means also more requirements. Okay, how do I need to control it? I need to make sure that I create the correct signal to deploy, to show the color that I want, to integrate sensors, for example, or also Bluetooth modules. All these we've taken into account. And as you can see on the screen, we have our libraries for GitHub for this Adafruit M0 microcontroller. We're working on providing the same libraries for other microcontrollers as well. So type Arduino or ST. We're always looking what the customer requirements are, what's being used in the market at the moment, so that we can support the customer in every way possible. Then, of course, we have this type of evaluation boards, this small display with the libraries. So as you can see here, we have examples of different texts, colors, animations. So everything is already inside the GitHub.
So this I can find online and download it for free? Or?
Exactly. The customer just downloads for free, install it in the microcontroller, so almost the same circuit as here. And then it's just good to go. You know, it's like a final application. And even in the system, you have integration with sensors, so you can display temperature, humidity, or even control it via Bluetooth.
Okay, so also good environment to just start and playing around and yeah, have a check for the own application.
Exactly. And last but not least, the new IC LED color calculator. This is a tool that we're offering in REDEXPERT, and it's just targeting a problem or a situation, better said, for customers who have the idea, how can I achieve a certain color, like corporate identity designs, or if I want to have two different LEDs produced today and tomorrow, probably there's a difference, you know. But let me just go to the next slide and I can explain you a bit more about it. In general, we're talking about semiconductors, okay, and it's not possible to have a one-to-one creation from today to tomorrow. So there's going to be differences. The color, the intensity, the characteristics of the LED of every single chip are going to be different. Doesn't mean that we have like completely different colors, or it's not going to be exactly the, I cannot achieve whatever I want. It's rather in the production, when we're having the whole LEDs are going to be measured optically and electrically to 100%. So we know from the beginning to the end of every reel what's inside. And during the production process, there's the sorting by characteristics. And we took this into account so that we can just group the LEDs in different boxes, different bins. This binning is, the customer gets this, is on the lot number of the label of a product. And then the idea behind the calculator is that you can always, independent of which batch, which bin you're getting, target the same color for your application.
Okay, so this tool is helping me. So I am just thinking about a marketing point of view. I am familiar with our WE red we are using. And of course, there is this RGB code. And I always want to have the same color because it's our CI. And so this tool helps me to get it for real and not those little differences which I get with semiconductors. Is this right?
Yeah, so it's the idea is exactly to target the same color, and these little changes that have to be done because of the production differences are going to be dealt via software, via our tool, and not because the customer just trying to go through all the combinations. You know, IC LEDs and this type of production, they have over 16 million different colors. And I think nobody wants to go through the whole list of colors. And now it's like, okay, how can I make the process more efficient and more simple for anybody? And this is why we brought out the tool. And this is just an example of what's happening behind. You know, the customer gets the LED. They select the lot number or the bin group to which the LED is from. And the tool tells you, hey, if you want to achieve this white, this red, this green, this purple, you just type the coordinates of the CIA 1931 in the tool, and it just calculates. You know, it gives you the RGB values that you have to send to your LEDs so that you can achieve this target color that you want. Not only that, we have also like the simulation on the other way, where the customer, instead of trying to select a color, they can simulate, oh, what happens if I give the LED, I don't know, from the 266 values, 56, 20, 50, 70, for example. What's the output of it? Can I somehow try to relate what am I expecting from our LED? And this is like the two aspects from the tool. And it's really interesting and innovative because this is the first tool for this type of LEDs in the market.
Okay, very interesting with this tool. I'm just thinking about, from my own experience, I bought like also a LED strip for my home to have this mood lighting, which we talked about already. But one of the strips got destroyed, and I bought another one, but it was like in another color. So the mood was not the same. So yeah, I don't know, because I pressed to blue, but it was kind of another lighting. Is it now better for the future? So is this, for example, now a solution to solve this?
Yes, exactly. So that's the point of the tool. You know, now we have this panel creation. For your case was light strips, but at the end it's just changing a part of the system. You know, and when you have like two different panels or three in here, and you say, hey, this one looks a little bit different. But I know my target color, I know what I want to achieve, I want the intensity, because I have the data from before. Then you can just input that into the tool, and the tool is going to just make the changes for that part of the system that you're changing. And now you have, independent on the panel or the LEDs or the time, the target is to always have the same color, the same output.
Okay. Thank you very much. So yeah, this was really a cool, cool points and a lot of insights we heard already. Are there some other things you want to show the customers now as well? Is something open?
Oh yeah. Now that you talk about it, we always say about these dynamic changes. How can I control one LED after each other? I already prepared a program with different examples, and now it's important to show like the customers that they can take a look. Okay, 2 clicks and my matrix that is here can be changed, you know. And what I did, well, now I'm uploading the information to the microcontroller, and the idea is to show you what the possible output of our LEDs is. So now the program is just loading. It takes a little bit of time. We're working with Visual Studio and Platform I/O. So it's connected to this Adafruit M0 microcontroller. Everything in the background is taken from our libraries from GitHub. And now after loading the information, you will see that the changes on the LED, this integration of these dynamic effects is going to be played on the screen.
Yeah, and for example, of course, now you're directly connected. You also told us about some Bluetooth modules, so also you are not dependent from the place, of course. So it's also, as we had also the application, I think, with traffic lighting or stuff there where you can't be there. So you just change it in your home office, for example.
Exactly. From any part of the world, it's also one of the advantages for here. And now you can see, you know, every single pixel, every single chip can be changed individually. It's independent on the position of your LED and all through one channel from the microcontroller, one pin, VCC line, ground, data. That's it. You don't need anything else.
Thank you very much. Very interesting. So I see the door is opening here in our studio, and Harun is with us. So cool to see you here, Harun. Let's have a seat.
Part and also invited.
Okay. I think it also fits for the camera.
Oh, thanks. So
Welcome.
thank you.
Nice to have you here.
Good morning together. Good morning.
Good morning. Yeah. So for you, Harun Özgür, nice to have you here as our head of global head of optoelectronics, and we also invited you to be here because you have a good view to the market. You are working a long time with LEDs in the sector of LEDs, and what do you think? What's current evolving in the market and market, and what do you think are the future trends? Where are we going?
Thank you first of all, and also, as I said, thank you that I can be here. The trends, I would say one trend is always to be more efficient. Then now it's coming more and more integrated to be smarter. So like controlling by voice, controlling by different types of, I would say impact. Then of course it's coming more and more to be more controllable. So controllable means that I can change the color, the spectrum of the light for different or individual aspects. One topic would be the human-centric lighting. So that as a general topic, I think everybody knows a bit about that. So you use that for, you need a different light for if you're waking up or going to bed or reading or working, just as an example. And I would say more controllable for the aspect of the application and even for your requirements. So, and that this happens very fast. Another thing is, which is close to controllable, is that you are manufacturer independent. So for the programming, so we have different solutions, I would say, now I need the English word for Bibliotheken. Libraries, you see.
That's why we are here.
And with different libraries, I think Carlos already mentioned a couple of solutions what we are providing already. So we do roughly, I would say, 80 to 90% or close to 100% what the market needs. And then, of course, providing, this is a trend more or less coming from us, is providing and be an enabler for the service. So what we did the past 2 years was to set up a software or create a software together with our engineers, which is called IC LED color mixing calculator, that you can easily adjust everything what you need with one software. So you can do it actively. So it means if you can change the color directly, you get it as in different languages, and also you put your color into it, and then it will give you the data and coordination that you have specific blue, green, or what else, which is important for CI topics, and also to be more individual. This I would say.
Okay. Achim, thank you very much. This was very interesting, and also we heard about the color calculator today. So also for you, if you have feedback there for us, then just let us know. And also with the word feedback, now we are nearly at the end of our session, and we want to also give you the chance to ask us some questions. So I saw already that we got some questions here in the chat, and for you, you can tell us your questions in the chat. If we can't answer your questions today, or you see this video online, then just let us know and we will answer your question by email. So then, first question to the round. How do IC LEDs or LEDs differ from analog LEDs?
So I think I can take that question. And it's important to mention LEDs itself is just our semiconductor that lights up and emits the color that is specified. So whenever we have something built up with more chips, we have a B-color, full-color LED, RGB. And the IC is just this RGB analog LED plus the controller in the same package, so to say. So that now we have this digital control inside the LED. And then we don't have to use single connections to every single chip. We can rather change, like here, around 128 LEDs with just one pin of a microcontroller.
Okay, thank you very much for the answer. Let's go to the next question. Which microcontroller or libraries are best suited for controlling the IC LEDs?
There we have examples like for this one, Adafruit Feather M0. We have also the microcontrollers from Arduino, Raspberry, ST. Important is that these microcontrollers can create the signal as required by the IC. And for that, you can also use the mostly SPI interface of the MCU. DMA, data transfer, works as well, or you can also use beat banging, but this is more complicated in the programming. Libraries, of course, we have some example on GitHub, so customers can always check on our website what's available from our side for service.
Okay, thank you very much. Then yeah, we heard something about the emissions. Now we have also a question. How does the IC LEDs react to immunity?
This is a question for you.
Sure. Yeah, so as Carlos already mentioned, we more or less using an SPI bus for the communication, and these buses are always critical regarding emissions, of course. This is what I've showed you before, but also regarding immunity. Especially when it comes to transient immunity testing, burst and ESD, for example, we can get some issues when we don't use a ground plane or when we split up the MCU PCB from the LED PCB. So we already discussed different options, how we can solve this, for example, when we shield the cable between the MCU and the LED panels. But for transient immunity issues, we can also use, for example, a software bug fix. We can send the data string not only once, but continuously. And when we will get a short interrupt, more or less, in the data string, you will get a small lightning flicker or something like this. But afterwards, you will come back to your required lightning. So that could be an option to solve this, not only by hardware, but also by software.
Okay. Cool. Thank you very much, Adrian.
Welcome.
Next question. How do you think are the IC LEDs in future evolving also in terms of IoT?
We could give a very short and specific answer to that. I mean, most important is integration. So I think there will be a bigger impact on integration of the product. So they will have a different, we see more and more applications with different requirements. And so with the requirements, you have different solutions. But overall, it will be IoT or will be a big topic for that, sure. That the IC LEDs are integrated to this environment and application, yeah.
Okay, yeah, I'm curious what will come, but yeah. So then I think we are coming to the last question for now. What happens if one LED fails? With the following LEDs still function? Will the following LEDs still function? Or still work? I'm just thinking of the Christmas tree, and if you pull out one LED, the whole tree is out.
Yeah.
It's not the same, or?
It's more or less, it has to do with the idea behind the question, and that's a really good example because, as you mentioned, the strings in the Christmas tree is just analog LEDs. So that means if something fails, then the rest of the strip just goes off. And with the ICs, we have this data transmission between LED and LED via the IC. That means if a chip just fails, so the color RGB, you will notice that something just doesn't light up correctly. However, in the case of the ICs, the data is still going to be passed by from LED to LED. That means your design, your drawings, or whatever you're showing, it's still going to be there. But in case the IC fails, yes, of course, then the rest of the string is going to be affected. For this reason, we have also specific products that work on this situation, like the 2121 IC with bypass. That means we have a secondary input as an option. So whenever the IC fails, you can just jump the LED, just bypass this, and therefore, yes, the string is going to be affected by one pixel or one LED, but the rest is still going to be unaffected.
Or even one color, one chip.
Cool. Okay. Thank you very much for all your answers and for your time today. It was really a pleasure for me. It was fun, and I hope you also enjoyed it. If you have any questions open, then just let us know. And for now, thank you. Have a good time. Have a good day, and see you the next time. Bye.
See you. Bye-bye.